Welcome. Thank you so much for joining us here today. My name is Benjamin Silver, and today we're going to be graphing functions on a graphing calculator and then analyzing them. So whether you love math or you're Miss Year who has to grade this video, I hope you'll find some enjoyment in what we're doing today. So we have this function, p of x equals x cubed plus 0.94x squared minus 16.0388x plus 20.3304. And what we're going to do is we're going to graph the function with an appropriate window, find the zeros, and then find the extrema. So the first thing we're going to do is we're going to type our function to our handy-dandy graphing calculator. And look at that, it's right over here. The function is already nicely, conveniently set up for us. And here we go, when we graph it, we get this shape. So we can see that the function is there, but there's something wrong. So we know that in cubic functions, there's going to be two changes from increasing to decreasing. And when we analyze our graph, we want to be able to see both of those changes from increasing to decreasing or decreasing to increasing. We see one of them is over here, but there's going to be a hump over here, a change from increasing to decreasing that we can't see. So we're going to adjust the window, and what that means is we're just changing the orientation so we can see a little bit more or a little bit less of the graph. So we need to see a little bit higher, so I'm going to change the y maximum to 60. Let's try that. And here the function is going to graph, and it looks like we nailed it. We can see both of these hump-like points that are changes from increasing to decreasing or decreasing to increasing. So now that we have an appropriate window, we can go ahead and start analyzing our graph. So the first thing we're going to do is we're going to find our zeros, or zero. And what the zero is a point where the graph intersects the x-axis. And we can see one over here, and there might be one over here. We can't really tell if it just approaches the x-axis or it actually intersects it. So to do this, we're going to hit second, trace. So it's going to bring up a menu under calculate, and we're going to press 2. And we're going to go to a point a little bit left of this first zero, try right here, and a point a little bit to the right of it. And it's going to bring us this zero, negative 4.980, comma 0. So now for the second supposed zero, we're going to do the same thing, second calc, or second trace, 0, and we're going to point all the way a little bit to the left of this second supposed 0, and a point a little bit to the right of it, and it's going to bring us to, and it says error, so there is no second 0. That means our only 0 is negative 4.9800. So the next thing we're going to do is we're going to find the extrema. And the extrema is made up of 4 main components. It's going to be the absolute minimum, the absolute maximum, the local minimum, and the local maximum. The absolute minimum is going to be the lowest point of the entire graph. The absolute maximum is going to be the highest point of the entire graph. The local min is going to be a change from decreasing to increasing. And the local minimum is going to be a change, or the local maximum is going to be a change from increasing to decreasing. So to find the extrema, we're going to hit second calc, first x out of this, second calc, and we'll start with the minimum first. And this point looks like a local minimum because it is a change from decreasing to increasing. So we're going to hit enter for a left bound point, enter for a right bound point, and our local minimum is 2.02, comma 0.013 or 0.014 if we're going to round to that thousandths place. So now we're going to find the local maximum. Second calc, maximum this time, 4, and we're going to go to a left bound point. Let's try right over here, enter, and a right bound point, enter. That's going to bring us to negative 2.647, comma 50.828. So that is going to be our local maximum. As far as the absolute minimum and the absolute maximum, there's not going to be one of either of them. And the reason is you can see that on this side, the graph keeps going down. There's never going to be a point where it hits an absolute bottom. And over here on the right, the graph keeps going higher. There's never going to be a point where the graph reaches a tip-top specific point. So that is it for our extrema. So there you have it. We found our zeros, extrema, an appropriate window. And I hope you've learned something from this video and hope you'll tune in again soon. Thanks so much and have a great day.